Pleasure to be here today. My name is Jeff Denworth. I'm a CMO, also a co-founder of Vast. And I'll be taking those of you that don't know us through a short introduction to our story today. And for those of you that do know us, I'll be sharing some new information just to keep things spicy. Okay, so I'm going to share my screen and we'll get at it. We have a new presentation template. That's a big update for those of you that have seen our last one. So that's exciting. So we're Vast Data. And the mission of the company is basically to democratize fast access to every byte of data within a customer's environment. The agenda today is basically, I'm going to walk through a company overview and update, provide a little bit of some of the Vast philosophy, which I think, we kind of forget about sometimes when we talk about what we're doing. And then Peter Gadd's going to come on. Peter is our VP of Sales. He is going to talk about our international expansion efforts and where we are to date and where we're going. And then Sven Brunner, who is our field CTO, will be taking you pretty deep into the technical elements of Vast and talking about what I call the consolidation imperative. So with that, let's go. And feel free to chime in or speak up. I don't need to only answer questions via chat. It's going to be a discussion if you'd like. Okay, so as compared to some of the previous presentations where I kind of framed the problem first, I figured for those of you that don't know us, I'll get right to what we're making, and then we'll dig into the problems and the solutions subsequently. And what we're building is an altogether new storage architecture. We call it a disaggregated and shared everything system. We call it the DAYS architecture. And what we've done is we've essentially endeavored with the company to do two things. One is to become an extinction level event for the hard drive. And the other is to basically bring an end to the last, 20 to 30 years of storage tiering that customers have wrestled with, as they've always faced a trade-off between performance and capacity. What we're building is a exabyte scalable system architecture that can scale asymmetrically over multiple generations of storage, allows customers to build a composable flash cloud. And the secret sauce here is that we've managed to build a system that is built entirely from NVMe flash infrastructure, but brings to the table for customers a economic value that's equivalent to what they're paying for their archives. And so what we've done is we've kind of optimized every single layer of the stack. We've built some very low cost components, and then we've applied a number of different algorithms that can only be done on this disaggregated shared everything architecture that allow us to get the delivered cost per gigabyte to be less than the cost of goods of the hardware when it finally lands to the customer. And so it's a new type of system that we believe is broken away from how customers have been trained. You need to build scalable infrastructure. For the last 10 to 15 years, starting with the Google file system, the market has been conditioned to think that in order to build for scale, you need to design a shared nothing cluster architecture where you have CPUs that manage some amount of the system state, and then you kind of scale out clusters using just nodes. In our case, what we build from is a collection of stateless containers that run our software. These containers, they over NVMe over Fabrics, which is a new storage protocol, have a global view of all of the underlying storage that lives in high density storage enclosures. And each container can see all of the system state. So imagine building a storage cluster where you had, let's say, 100 or 1,000 controllers. In the case of 1,000, you could lose 999 of them and still be entirely online. As containers scale into the cluster, no two containers have to talk to each other in the read or write path for reasons that all of them can see all of the data within the cluster over a very, very low latency commodity network. Now, systems from a performance perspective can scale linearly. You can start to compose systems in new ways. And most importantly, that global view of the namespace that our logic enjoys, it allows us to apply a bunch of new efficiency algorithms, both on the topic of data protection, data reduction, and then also how we manage flash and manage to get 10 years of longevity out of very low cost flash. And so we're going to take you into the architecture in a very deep and meaningful way, but I just wanted to start and kind of frame what we're selling for those of you that are uninitiated. It should also be clear that what we're not making is today a distributed block storage system. When we looked at the market opportunity, we concluded that file and object storage was the best place to be selling high capacity flash infrastructure when we started the company in 2016. And so today we offer services for NFS, S3, SMB, and we consciously make the decision not to add things like custom client-side drivers and provide software that has to sit in a customer environment in order to drive the system, because when we looked at the market opportunity, we realized that those types of technologies typically tend to complicate customer environments. And for us, NAS and standard object protocols seem to be the easy button that customers could consume from. And if we could just get the performance impediments out of the way that people have historically wrestled with respect to NAS, you can do some really interesting things. So Sven's going to be showing you what we've done on that topic, but understand that this is a system that is fast enough for your most demanding applications. It's cheap enough such that you can afford to put all of your data on it. And it's scalable enough such that it actually can encourage this consolidation movement towards just building a single tier of flash across your data center. Okay, so the company really specializes in kind of rethinking how storage has been built. And a lot of what we talk about is around breaking trade-offs that have saddled both architectures and also the principles by which customers have deployed storage into their environment for the last 30 years. And I'm going to walk you through a few of these trade-offs today and explain how we've changed the paradigm. But there was it's funny, before we actually launched the company, we made this values video. It was kind of modeled after the Think Different campaign that Apple did. Obviously, nowhere near as good as how Apple did it. But there was a line that kind of was written into this video that 5 years later I really appreciate. And the line talks about how we approach problems, and you kind of reduce the problem in order to expand the potential. There's so many things that storage companies do, and there's so many things that customers do on a daily basis because they haven't challenged the underlying principles of how storage should be built or deployed. And I think that's what we really focus on is kind of making sure that we understand what the core of the problem is. And so the first trade-off that we've broken is the fundamental trade-off that's been in the market for the last 30 years, where customers have always had to choose between performance and capacity. And this one is so pervasive across the market. Every single customer that we encounter has n number of different storage technologies in their environment. And for the last few decades, they've been trained that they have to buy storage technologies based upon a spectrum of capability, where on one side you have performance, and on the other side you have capacity. Well, through the application of some new technologies, what we realize is that first and foremost, it's possible in 2020, 2021 to build a distributed flash system that comes in at the cost of your hybrid or your hard drive-based storage. And so this in and of itself was an interesting development. And the interesting thing from a flash perspective is that once you make the evolution beyond hard drive-based storage for all of your data, then capacity ultimately becomes performance. If you think about the flash drives that people were buying 10 years ago, they were 1/10 the capacity, as well as 1/10 the performance of what we could buy today. And so unlike hard drive-based infrastructure, flash doesn't represent that trade-off that customers have always had to face. But at the system level, we needed to apply new thinking. And it was actually a conversation that we had with a Fortune 1000 customer, just as we started kind of going out into the world and socializing our idea. They basically said to us, they said, if I can, why would I put my my snapshots in another storage system if it's less expensive for me to keep them in a VAS system versus putting them into some backup appliance? And we hadn't really considered building a consolidation play into the strategy up until that point, but we realized there essentially is no reason to go and federate to different tiers of storage once the cost arguments are gone. And so the number one kind of element to our strategy is that we've completely redefined the cost of NVMe infrastructure such that customers can afford it for all of their data. Now, when I talked about this idea of reducing in order to expand your potential, I can tell you that every day we're talking to customers that are quite happy with their tiered infrastructure. And then when you start talking to them about how they manage their data across it, they say, okay, well, you know, probably about half the meetings that we have in a week are around how to work with our users, our application owners, about their capacity management strategy. And we work with them to move their data back and forth between these different tiers to save us money. And so that is wildly inefficient use of people's time and their energies. But more importantly, what nobody is talking about is that just puts the burden of data management really at the feet of a user, of an application owner. And the reason for that is that they have to wake up every day and figure out how to wrestle that trade-off that their storage team or their IT team has imposed on them. And so we look at it from a different perspective and say, what if you didn't have to deal with this problem at all? And for this reason, we came up with this concept called universal storage. And the interesting thing is that as customers are now acquiring the product, they're making the decision not just for VAST, but they're making the decision for consolidation. They're making a decision to no longer buy hard drives in their data center at all anymore. And that can become such a powerful and transformative decision. Now, how we do it is through the application of some new hardware. We were the first company.
Sorry, I have a question, if possible. So you talk about universal storage, and I'm familiar now with what you do and everything. Why didn't you add a block storage protocol in the front end to make it truly universal? I mean, you have files, you have NFS object, but not iSCSI or NVMe over Fabric or something like that.
It's a good question. And so there are, I would say, 2 to 3 reasons. The first is time. It just takes a while to make this stuff. There's nothing in our architecture and our data structures that would preclude us from building a block store. We haven't done that yet. The second is in terms of the applications. So when we looked at the problem, people would ask us, as you mentioned, why don't you have a block interface? Other people would ask us, why haven't you built something like a parallel file system or HDFS connectors and things like this? And what we concluded is that if you look at the application of block storage within most customer environments, people tend to think about block storage as, I'll go back one so we don't kind of confuse the content. People think about block storage as being able to provide sub-millisecond latency access to data sets. And as we started to look at it, you can use NFS for VMware. You can use NFS for containers. You can use NFS to build databases. You can use NFS for almost anything that doesn't require SCSI persistent reservations. If you can build one solution that kind of gets the latency of NFS in check, then the motivations towards block storage are diminished versus how people have kind of not been able to use NAS up until now. And I understand that there are still applications that require some block interfaces, and we may do that in the future, but understand also that we don't need to be a $10 billion company in our first day of operation. So we just had to make some choices. The second consideration is when we looked at the data within a customer's data center, roughly, I would say about 85 to 90% of that data was on unstructured data storage systems like file or object stores. And so it was the bigger opportunity for us to start with. On the topic of HDFS, the same considerations were made, but here we realized that S3 was quickly overtaking HDFS as the kind of the de facto standard for big data environments. So we realized that we had a good solution with fast object. Okay, so how we do it is by not only breaking at the fundamental level, we've broken the trade-off between performance and capacity. But in order to do that, we've had to break like what I would think of as micro trade-offs around the application of technologies within a systems architecture to essentially reconcile what was previously a very large gap between the cost of flash infrastructure and the cost of hard drive-based storage. The first thing that we've done is we've enabled an architecture that supports QLC flash. Most vendors that can use this, and many can't, but the ones that can would regard this as archive flash. We use it for highly transactional environments and some of the most demanding computing centers in the world. And the way that we can do that is by breaking the trade-off between endurance and cost. We get the low cost of QLC, commodity, or hyperscale media. And what we've done is we've applied a number of different algorithms within our system to essentially shape writes as they go into the system. And after we started shipping our QLC-based system, Intel started promoting a second endurance rating, or the ability to overwrite these drives. And they determined that using a very large block size, which we can issue thanks to the write buffering that we do with a new type of persistent memory that comes from Intel called Optane technology, you can basically shape writes into these QLC drives and get 20 times the endurance than what Intel originally was advertising. So this brings the cost of goods to a point where we think it's within spitting distance of hard drive infrastructure, but it's not cheap enough. And so the second thing that we've done is we've broken a trade-off between resilience and overhead. People always measure RAID by how well am I protected versus what's the cost for that. In our case, we've built a very wide striping data protection method that can get to 60 million years of mean time to data loss. At the same time, our customers are only paying 2.5% for data protection. And so now organizations get so much more free space back from their system investment than any other storage technology that would typically have between 30 to 40% overhead for data protection. The final thing that we've done is we've broken the trade-off between efficiency and scale. And what I mean here is that most data reduction engines, the most fine-grained ones, will be able to reduce data on a block or a file basis using compression. And as systems have grown, what organizations realize is that deduplication can be used for much larger data sets. The problem is that as you move from compression to deduplication, you lose a ton of optimization, because as opposed to looking for patterns within 2 bytes, deduplication systems try to reduce data in discrete 32 kilobyte blocks on average. And so if you have 1 byte difference between 2 blocks, they won't reduce. And what we've done is we've pioneered a new form of data reduction, which you could think of as roughly equivalent to global compression. It has all of the advantages of deduplication in that it goes across your whole namespace. But at the same time, the pattern matching is 1 over 32,000 times more fine-grained and much less sensitive to noise in data than deduplication works. And these 3 advantages compound: very low cost infrastructure, very low overhead RAID, and then a novel approach to data reduction, which gives customers on average 2 to 3 times more systems efficiency than what they would get with any other system. And when you put it all together, we deliver the cost argument that customers can now use to basically go and eradicate the hard drive from their data center. And it is happening. So I wanted to share a few customer stories. This is one that we work with. It's an organization called SquarePoint. They're a team that formerly worked out of Barclays as their systematic and quantitative trading team. This is an organization that spoke at a webinar we ran a few weeks ago around a new consumption model that we launched called Gemini. And they've scaled to multiple petabytes of data over multiple generations of hardware. They're not buying hard drives anymore. And they're even doing things such as repatriating data from very low cost archive services like Google with a simple solution that provides them archive capacity. And once they started to put all of their archive on our system, they realized that by virtue of the fact that they could afford 10 times more flash than what they previously had, performance just comes for free by virtue of the fact that they need to put all of their data on flash. And so, yeah, sure.
Yeah. Hi. What were they sitting on in the what kind of storage were they using up in the cloud?
This is Google Archive storage.
They're using Google Archive. Okay, sorry, I missed that.
No, it's okay. And on-prem, it was a mix of different file system technologies, both enterprise grade and high performance file systems. And now they've kind of consolidated, I think, 12 different types of storage onto one platform. And for that reason, that's why we call it universal storage. It's just a one-stop solution for the firm's use cases. Okay.
Beth, again on that one, can you talk about the financial implications of what that looked like for them and kind of with the repatriation?
I can't, well, I don't know what they were spending. I only know what they did, but we do very exhaustive cost analysis against cloud. And actually, this is the slide that I have up here. And most of the kind of low cost object services within the cloud cost you roughly a penny per gigabyte per month. Mm-hmm. The high performance services can cost you anywhere between 10 cents to 30 cents per gigabyte per month. For example, like just standard enterprise file services in the cloud cost you about 30 to 40 cents per gigabyte per month. I can tell you that customers are amortizing their whole vast investment within the envelope of what they would be spending for roughly a month of high performance storage within the cloud. So over a 5-year period, that's 1/60th the cost that they would spend. But we're also cognizant of the fact that people aren't just doing, only putting their data in the most expensive tiers of storage in the cloud. They have a mix. They have a tiered environment, just like customers have on premises. As measured against something like S3, customers typically save around 50% when you account for administration, you account for data center footprint as compared to using VAST. Now, the big consideration there, though, is that no customer is using exclusively S3. They also have some sort of higher performance storage that they're actually doing their computing on. And our approach is, well, what if you could deliver a system that was half the cost of something like S3, but at the same time give you performance that's equivalent to or in excess of the high performance flash options in those clouds. And so when you kind of put it all together, customers save on average about 70%. And I came up with this number after going and reviewing our TCO calculator that was created by Howard Marks, who, if anything, is extremely detail oriented in terms of how he puts these things together and doesn't like cutting any corners because he typically hates vendor TCO analysis. And the story here, though, is that what you can build is a multi-protocol unified data experience that is, there is no equivalence within the cloud data center. And this is one of the kind of the fundamental analysis that we did when we started the company. We said, okay, if we're going to do something in the era of cloud, how can we be sure that we can succeed? And when we looked within the cloud data center, what we found was all of the kind of the same concepts and paradigms that customers have been wrestling with on premises sold back to them as a service now, which is obviously easier to deploy, but doesn't reduce that fundamental problem that we were talking about earlier in terms of the compromise between performance and capacity. And so this is an interesting time, and I wanted to be a little bit provocative here, but if you happen to catch a conversation that Andreessen Horowitz was driving 2 weeks ago, they pretty much put companies like Amazon and Microsoft and Google on notice by articulating the added expense that comes from deploying in cloud infrastructure. And what they estimated is that about $500 billion of market value, market capitalization, has been lost because of the added expense of the cloud. And we think that cloud has for sure a time and a place, but as customers get to a certain level of scale, a certain level of critical mass, what happens is they realize that the savings that you get from an administration perspective are far outweighed by the expense that you incur by buying services that are so much more expensive than what you can build on premises. And so we're routinely working with customers that are initiating data repatriation projects as they get to that level of critical mass. And it's a very interesting time for this topic. I can say that. Okay. So the third trade-off that we made, the third trade-off is one around scalability. And I think, my team has been we're hiring a bunch of people. The company is around 250 people now. We're tripling in size every year. And as I hire new people in the team, they ask for what's that one simple advantage that we can tell customers that we do. And I think that the interesting thing here is that what we've observed is that as customers started to scale out their legacy infrastructures, whether they be hard drive based or flash based, oftentimes they find that scalability can be very troublesome. System uptime becomes a consideration, administration burden becomes a consideration. And what we do is we spend an outsized amount of our investment, not only in making architectures simpler to deploy and scale, but also a ton on QA. And so our customers are now operating in the dozens of petabytes range and remarking to us that it's just a platform that they don't have to worry about. They don't have to babysit. And this becomes transformative as you start to think about how to kind of like deploy infrastructure, particularly as vast as advising that you go and you consolidate. And I kind of think about the hierarchy of needs that your average storage buyer has, and reliability and simplicity are the things that basically make sure that they can stay employed. And then secondarily, people consider things like performance, price, and I use the word cachet here, with the cool factor. And that's what you use to basically get promoted. But people are making extremely large investments on VAST. And the reason that they can do that is not because it's fast, it's not because it's cheap, it's because it works. And our biggest customers have bought in excess of 10 times since their first investment in the last 12 months for that simple reason. We've redefined resilience and simplicity at scale. And the way we can do that is by pioneering an altogether new systems architecture. And as I mentioned earlier, a lot of the products that we're competing with are thought of as shared nothing systems that have a node with some CPU, some memory, and then maybe a few SSDs and maybe a few hard drives in them. And customers kind of build out their storage by adding these nodes. But what these storage vendors don't tell you is that every single one of these nodes is a single point of failure. Within itself, obviously the clusters can withstand larger failures, but each of these nodes, because they all own a portion of the overall storage environment, they all have to talk to each other. And this creates internal crosstalk within the system. As nodes fail, you have to rebuild data, and this creates a lot of rebuild traffic. And most importantly, there are interdependencies within this cluster that tend to grow geometrically with cluster size. One of the largest scale-out NAS vendors in the space uses a term indeterminate operations. When a node receives a request, it has to talk to any n number of other nodes within a cluster in order to satisfy that request. And if any other node is having a bad day, this creates a ripple effect within a cluster. Now, in our case, this new storage architecture that we pioneered, this DAYS architecture, each node has direct and global access to all of the SSDs and all of the cross-point drives within a cluster. And that's over a new storage protocol called NVMe over Fabrics that basically has direct attached storage latencies. And so we've gotten rid of things like cache coherence because you don't need nodes to talk to each other because there's nothing cached in our system. We've gotten rid of scalability bottlenecks by making sure that these nodes don't talk to each other and create an outsized amount of cluster crosstalk. And we never have to rebuild data when a machine fails because everything is completely redundant within our system. And at scale, that becomes a really important factor. Like we have customers that are building large 100 petabyte plus hard drive based systems, and they're rebuilding all the time, not only because drives fail, but because nodes fail. And so this new DAYS architecture is basically challenging how people can build resilient systems. And here we think we're doing something that is making it easier for customers to consolidate. Now, let's put a fine point on this. Last quarter, our average customer investment, the average sale we did was $2 million. We got more than one customer, you can be sure of that. Our largest customer to date has spent over $25 million with us. And I think I have it. Yeah. So our largest customer today has spent over $25 million. To put that into perspective, that's more than many storage startups have sold in their history. And that's just one customer of ours. And we now have multiple customers that have invested over $10 million, some of them on their first purchase. And so this whole idea of scalable simplicity is something that I think the market needs in 2021. And this approach allows us to not only, from an architecture perspective, build something that works, but we also, from a business model perspective, these customers are spending enough money with us where we can basically blanket them with the comfort and support that they need to make decisions. And I like to say that storage is generational. People are making storage decisions generationally. And I don't mean by hardware generations, I mean by administrator generations. One of the companies that we compete with is Dell on their Isilon product. And we're talking with customers that haven't made a new decision for scale out storage for the last 15 or 20 years. And so the muscle memory around how you go and pioneer new architectures into your environment, and a lot of customers are just gone. And so how do we solve this problem? Well, we've created a program called Copilot as part of our Gemini offering. And we're, of course, watching all of the infrastructure for customers as part of our management service. But what we've done is we've combined the systems and the accounts with basically a level 3 engineer that's partnered with every account. We can do this because our customers are spending a lot of money with us. And basically, they handle everything. They handle all of the daily monitoring. They handle all of the customers' feature prioritization requests. They handle all of the expansion planning, all the installs. They handle everything for a customer. So the only thing the customer has to do is provision a share or provision a bucket out to their users, but there's no amount of administration that needs to be done. And so this has become a really popular program with our customers, and everybody gets it for free. It's not something that you have to pay for. These co-pilots, you could think of as private cloud storage operators that basically work for our customers. And so that's one of the kind of enablers for simplicity at scale. And what we're seeing as we go into the second half of the year is that things are getting really interesting, where the success that we've had previously will be dwarfed by the projects that we're doing now, where we've got multiple 50 to 100 petabyte clusters that we're working on building with customers right now. So we expect it to be, we expect the trajectory to be very exciting as we go forward, just as it's been up until now. Now, I'm a big believer that you can have a cool technology, but unless there's a market driver that will create an opening for a new technology to enter into a customer environment, you're not guaranteed success. And I think it's very clear now that AI is the killer use case for distributed flash architectures. And the interesting thing from an AI perspective is it completely changes the AI and the application paradigm that customers wrestle with. Right? If for the last 30 years, if we wrestled with enabling fast transactions, as the transaction ages, the value gets less and less, and you kind of deprecate that down to some other lower tier of storage. The opposite is true for the age of machine learning and big data. These models and this analytics, it only gets more accurate as you expose it to more and more data. The concept of a storage pyramid is basically turned upside down by the needs of machine learning and big data, where they want the fastest access randomly to the largest amounts of storage that a customer can expose to these codes. And so what we're seeing is that speed, scale, and resilience become predicates for how people think about enabling their machine learning agendas. And this is the kind of the compelling event that we think will propel us to become the next great infrastructure company. Now, Sven will talk to you a lot about what we've done around breaking trade-offs between application performance, and simplicity. And people oftentimes, up until now, and Enrico, I think you clued into this, they kind of malign NFS for being a slower protocol. And what we've done is we've gotten a factor of 80 improvement on NFS from where customers have come from. And that becomes kind of an enabler for organizations to start to consider enterprise utility that can go and enable their AI and machine learning initiatives. And customers, actually our sales team always asks us, like, show us where the AI projects are. And the question, I think, is fundamentally flawed. And we look at the market opportunity for AI, and every day we're seeing evidence of the fact that AI is now being infused into every application. And so our job is to basically modernize your data by putting it onto a system that is accessible from a very simple perspective. We're just offering an NFS storage system, but can work with AI at any scale. And Sven's going to tell you how that works in a moment. I don't want to steal his thunder, but the big trade-off that we've broken here is that you don't need to go and build exotic infrastructure to go support these AI initiatives. And you shouldn't, because at the end of the day, AI will be woven into every single application that you run. And for us, being a general purpose storage product is absolutely critical to our strategy. And we see evidence of this being a real thing as we work with customers. Another customer we have is an organization called Zebra Medical. And this is an organization that before we started working with them, was building a tiered storage system. Had a large flash file system that was back-ended by a hard drive-based object storage system. And what I said earlier about AI just randomly reading through all of your data, what the organization realized is that, whereas these tiered systems, they help when you want to do a declarative write down to storage and get fast write performance down to your environment. But from a read perspective, if that data has been locked in some low-cost object storage system, there's no amount of performance that you'll get from having a flash front end. And actually that flash front end becomes a performance bottleneck. And so they actually returned this system that they acquired, and they just bought some VAST. And it's really simple. You don't have to make any decisions about where your data is. It's all on fast NVMe flash. They got NFS over RDMA such that they got all the application performance that they need. And now they're not managing infrastructure, but more importantly, they're not managing their data because they don't need to anymore.
Jeff, how did they actually know that you existed? You said they just bought some fast. How did they know that you were around? They have some relationship with you already?
They didn't. We had a friend of the company that just made an introduction, and timing is everything in a lot of these cases. And when we got engaged, they were like, "Funny that you should tell us this story." And from then, we've had a very good relationship. This is a company that we sold to even before we came out of stealth mode, believe it or not.
Interpersonal relationships matter.
They do. They do. I think probably most of the early business that we built is on personal relationships. We're fortunate to have some really good channel partners as well, but a lot of it was who we knew. Okay, trade-off number 5. Flexibility from a software perspective versus giving up that flexibility. When customers want to do a software-defined project, they find that oftentimes that results in finger pointing between their hardware vendor and their software vendor. And now you have to go and qualify all sorts of different infrastructure. Customers like the economic advantage of buying software, but no customer likes building an integration project to go make it work. And so about 3 months ago, we announced an altogether new commercial model that we call Gemini. And up until now, we were basically just selling storage appliances in the same way that a lot of the big box vendors were working. And the reason that didn't work for us in all cases is really on 2 ends of the spectrum. We sell a purpose-built storage appliance that has a minimum capacity of 675 terabytes. And so not every customer needs 700 terabytes of storage to start. And oftentimes we would find ourselves kind of wrestling against the gross margin profile of the entry deals that customers wanted to do. Somebody wanted to, let's say, license 100 terabytes or 200 terabytes. at the end of the day, it didn't really matter from the perspective of our books, because we would just show that we were producing less gross margin than what our business model was designed to do. And on the flip side, as I mentioned, we're selling 100 petabyte plus systems now, and some of those customers are taking the economics of the deal to a point where they don't look like a classic kind of enterprise storage gross margin profile. But that's okay, because we make up for it in volume, but oftentimes that doesn't get appreciated with respect to financials. And so what we realized is that we could change the game. And we've done that by doing a few things. This program that we call Gemini, first and foremost, what we've done is we've disaggregated the business model such that customers now buy hardware at cost, or we would argue below cost, because with the appliances that we're selling, they're all kind of pre-negotiated. And oftentimes when customers are receiving equipment from us and they're seeing the cost of the hardware, they realize that they couldn't buy this at the same level themselves because they don't have the same buying power. But at the same time, they're still getting an enterprise appliance. And what I mean here is that there's no amount of configuration or integration work that a customer has to do. It all comes to you as a dedicated appliance where you buy hardware at cost, and then you license our software on top of that. Now, Gemini is also really interesting because we realized that by disaggregating the hardware and the software, we no longer sell storage like other storage companies do, where they kind of try to compel the refresh event. And the reason for that is that if you're just buying a storage array, storage salespeople don't get paid unless you go and transact another array. Well, that doesn't work for every customer. And we realized that by disaggregating the hardware and software, customers can manage hardware on their own agenda, and they don't have to pay a refresh tax, because every time they buy hardware, it's independent of their software investment. And so now we now have customers that are thinking about doing things like refreshing their equipment every time we bring out support for a new hardware platform. And the reason for that is that the cost is so much lower than if they had to go and recover the investment that they made on software. They're totally independent. On the flip side, because our salespeople don't get paid on selling hardware, we have other customers that want to just keep the hardware on the floor for a decade. And that's totally okay too. Now, the big thing is that as an asymmetric storage architecture, people can build multiple generations of hardware into a single storage cluster, as they've already done with VAST. And you never have to worry about where your data is. Our software all manages that in the background. And so what it means is you never have to migrate your data again once you get onto this paradigm. And our architecture makes it possible to just have an infinite storage lifecycle. Now, the third element of Gemini is a set of investment protections that we provide to customers that take the risk out of adopting universal storage. And we're covering everything from making sure that you always get all the software features as part of being a Gemini customer, making sure that we guarantee that customers get the best possible data reduction, or we pay for the difference in capacity. We guarantee customers will never have any downtime event because of the loss of a specific server, because we have this stateless, non-cached architecture. And these are things that nobody's ever done. And so our zero compromises warranty is basically another commercial protection that we put on top of the product that basically makes sure that as customers start to develop up that muscle memory again about buying new infrastructure, that they know that there's no risk associated with doing that. And then finally, Copilot is a big part of what we announced with respect to Gemini that I already talked about. Now, it's a little bit abstract. So, the way that it works is that, our hardware vendors will ship equipment to our manufacturer, which is Avnet. Avnet will then go source the software directly from VAST. And then what gets delivered to the customer is an appliance, right? So from a purchasing perspective, it's no different than the appliance selling motion that customers have kind of enjoyed throughout the last, few decades. But at the flip side, they now get the power, right? And when we start exposing our costs to, in particular, some of our larger customers that maintain relationships with a lot of the vendors that we work with, it allows them to maximize their buying power, both by taking advantage of our sourcing agenda, but also at the same time, taking advantage of the relationships that they have with their vendors, and a few hyperscale companies in particular really enjoy this kind of transparency. But what we wanted to do absolutely is make sure that there was no finger pointing, no complexity with respect to this sourcing model. So we provide all the hardware support. We do all of the telemetry. We're monitoring everything 24/7, and customers have no integration complexity to deal with. And so that's why we say you can basically buy like a cloud vendor. You can get down to the bare metal in terms of cost exposure. But at the end of the day, even some of the biggest cloud customers that we talk with and that we work with still want that advantage of buying a simple turnkey appliance. I'll just pass through this one. I think I'm talking a little bit too much. Okay, so one of the other trade-offs that we've broken is not around our architecture, not around the philosophy of how you deploy infrastructure, but it's one around how we built our business. If you've not encountered VAST, then I would say that we should be doing a better job from a communications perspective. But one of the things that you may not realize is that VAST has recently been valued as the most valuable private infrastructure company in history at $3.7 billion. We just took our Series D funding. Now, the interesting thing here is that the investment excitement was basically driven by not only our very fast growth into the market. We exited last year at around $150 million of annualized run rate. We sold about $100 million of software in just 2 years. We're tripling the business every year. But what we've done is we've built a more efficient business than companies that have come before us. And even when we started the company, our investors were thinking we would need to basically spend $1 billion to sell $1 billion, just because some of the other really successful IPO grade infrastructure companies, that's how they built their businesses previously. We exited 2020 cash flow positive. And the way that we can do that is by not focusing on going off and selling $50,000, $100,000 systems to 10,000 customers, but selling a much higher ticket product to customers that care about scale. And so we just have such a smaller sales and marketing team as a result, because at the end of the day, if you're going to sell a $100,000 system or a $2 million system, the selling motion costs about the same. The difference is that you get 20 times more money as a result. And so this has been a really exciting time, because people are realizing that we can build an altogether new type of business. And with just 250 people at $3.7 billion valuation, I'm not even talking about storage or infrastructure. VAST is one of the most successful startups in the entire IT space right now, as measured by our valuation. And so we're expecting to continue this capital efficiency story as we move into 2021. We're investing very heavily in the company, even though we're maintaining this capital efficiency. And the reason that we can do that is because customers are making very large investments in our product. Okay.
Are you also going to cover the geographical markets that you plan to move into more?
Yep, that's Peter Gadd's playground, and he's going to be talking in like 3 slides. Okay, so one of the questions that came to us before the session was, who are you competing with? And so last night I went in and dug into Salesforce. And as measured by the number of deals, this is basically who we're taking out by who the incumbent systems provider is, and then also who we're winning against when we look at, okay, if the customers made a decision to move beyond an incumbent, they put another collection of vendors against each other and they go scrap it out. And so, I would say that the product that we're most competing with is Dell EMC's Isilon product, but we also see a whole collection of other technologies in play when customers are thinking about just consolidating all sorts of other technologies. We have cloud vendors that we're competing with, backup appliances, and a lot of object storage. Increasingly, if I look at the more recent deals, there's a lot of object storage competitive deals. But this is basically this on the basis of the number of transactions that we've done. And I think it's probably a pretty good proxy for what we'll see for the next 12 months as well. Okay, so that actually probably this slide should have been preceding the one previous, but I just wanted to put a finer point on how we think about building an efficient organization. We took our first 2 years of revenue and we stacked it up against some of the more successful companies that ultimately IPO'd in their first 2 years. And then we looked at the head count that we had exiting those 2 years, which is disclosed in the S1s of these companies. So we could go back and kind of do the fact checking. And so, you know, the really interesting thing is here that our team is just outperforming the benchmark by roughly a factor of 2 versus some of the more successful companies in the space. And this is how we basically have managed to get to that capital efficiency. But the other advantage is that, you know, as we get into a customer environment, they say, okay, what do I do with it? And, you know, to the point I was making earlier about universal storage, we kind of in a glib way say really everything. And so we have vertical solutions. We've got a lot of customers in the life sciences space. We work with some of the world's largest hedge funds, content production and distribution over the internet. Some of the most popular streaming services are built on VAST. And then we work with many of the world's largest high performance computing centers, even though it's just a simple NFS appliance. But that's not where the story ends. We also have horizontal solutions. It turns out that our data reduction works really well with backup data, even after the backup products have applied their mechanisms. We're working with a lot of customers, both on AI projects, as I referenced earlier, but also big data tools like Spark and Presto. And then what kind of is the most general use case, I would say, is that enterprise infrastructure projects are being deployed on VAST, simple container projects. And then a surprising number of VMware workloads are now starting to be deployed on VAST. And so this is why we call it universal storage. There's really nothing you can't do with it, as I mentioned earlier, with the exception of a few workloads that actually require certain block primitives. Most don't, but they just prefer block. And this also becomes kind of critical to our expansion strategy. And I talked earlier about customers that have invested 10 times within a 1.5 year period. The reason that they can do that is because they just find so many additional workloads that they can run on this platform. And so that's the universal storage philosophy, and that's our mission. We're basically democratizing.
Yeah, sorry, can I just interrupt and give you a brief second to take a breath? We've got a question on here from Tony Locke, and he says, are there guidelines on HW specs to purchase to guarantee service levels, etc.?
To guarantee service levels.
Essentially to guarantee the performance, to guarantee the resilience, the lifetimes, or are you relying on your third-party partners that are doing the sourcing to make sure that they're actually sanity checking the hardware and it's not just any old junk that's being put in? Granted, the model that you have can deal with, you know, most types of physical hardware, but, you know, presumably you have some guidelines on quality for there.
I would argue that it is wickedly rigid in that there is only one platform that you can deploy on, and that's the platform that we've specified that Avnet sells. You can't run our software on anything else.
That wasn't clear to me when you had that. Okay, fine.
And that's how we deliver that appliance experience. Our engineering team is working with these hardware components every day. Our QA lab is about $20 million of equipment right now. And we basically run this on one platform today.
And Tony, so to build on that, we also, our license cost includes hardware support.
Yeah, sure. No, it's just that it wasn't clear from the way you described it earlier. I was interpreting it in completely the opposite fashion from the use of the language that you had.
Sorry about that. Okay, so just recapping, our job is to democratize flash for all your data. And once you've done that, you can democratize consolidation. You don't need 15 different types of systems. You can start to really bring everything down to one platform. It becomes easier from an administration perspective. Your applications are all enabled with all flash resources, and you're no longer looking for your data because it's all in one place. And once it's in that place, it becomes ready for next generation applications like AI. And we've essentially unlocked software value without bringing complexity to the table, thanks to this Gemini offering that we built. And then the real evidence of this working, I mean, really working, is that from a historical perspective, we're breaking all of the benchmarks by breaking trade-offs. So with that, I will turn it over to Peter.
Thank you very much. So I'm Peter Gadd. Thank you, Jeff. Excellent. So I'm not going to take too much time because I've seen about 10 questions where Sven is going to cover in his section at the end. So I think he's got a lot of work to do. My name is Peter Gadd. I've been with Vast since October. I came on specifically to start building out the international markets. I just talked a lot about the hypergrowth and what's happened over the last 4 years since the company was founded. Clearly, it's been incredible success, and the last 2 years of trading has showed some real hypergrowth and the fastest growing company in our space in all time. Now it got to a point at the end of last year that if we want to continue with that hypergrowth and really service global clients, we have to expand into international markets. The good news for me taking on that role is that we've had 4 years of really excellent proving ground in the US. We really understand the use cases that resonate with our customers, where we drive out cost, we increase efficiencies, we have massive business impact. We know the markets, we know the verticals, we know the use cases. This has made my job a lot easier. It means my job becomes one of operational excellence and execution. What that meant is I can go out and hire exactly the right people to address these markets, exactly the right people to address the accounts, and we can scale and grow hopefully faster than in the US did relative terms, because we're no longer proving, we're executing. So, this has been a really big, can we get to the next slide, Jeff, please? So since October, these are the territories where we either have direct sales or significant partners. If I talk about, probably a really good way of describing the geographies we've moved into is where we've got real customers or we've got significant proof of concepts taking place. And I can tell you in APJ, we have both of these things in Singapore, Japan, Korea, Australia, and New Zealand. Across EMEA, we're already having these conversations, all customers in UK, Germany, France, Israel, South Africa, Saudi, Middle East, Nordics, Benelux, and we're having some really interesting conversations in Russia and India. So this has been very fast growth. We are already in the hundreds of millions of pipeline, and we will end this year in the tens of millions of revenue. I'm delighted that quite a few of the companies that Jeff talked about, starting at $10 million and 50 petabytes plus actually sit in this space, that they're over here. So we're expecting really, really rapid growth. So we've built a very good team. We've got 8 players in who are really addressing these markets, are really executing very, very well. On top of that, we're building a channel and an ecosystem that will really support and accelerate this growth. So if we look at the next slide, please, Jeff, these are just some of the channel partners who have let us use their logos. But, again, as part of the execution piece that I talk about, we really, as you can see from this, we're looking at not a traditional storage channel. These are channel partners who can really add the business value into the space that we want. These are, NVIDIA's partners, Intel's partners. We can really get after, the big applications and the big business opportunities where we know we can make a massive impact. I think in all the years that I've been doing this, I've never known a channel partner adopt an early technology company as rapidly and as enthusiastically as the channel partners have over here. It took me several years in my last business to get anywhere close to some of the names on this list. But, I do believe that the channel have really recognized the disruptive nature of our technology, the amount of revenue that's likely to come from us, having the business impact that we will, and the fact that we're building something very, very different. We are really building the next flash private cloud that's going to be far, far superior to anyone else in the market. Coupling that with the license model that Jeff talked about with Gemini means that, we are literally taking away all the forklift upgrades. I think Jeff was a bit gentle when he talked about it. you know, we are taking away forklift upgrades. We're taking away the 3-5 year maintenance extortion that we've lived through for many, many years in this industry.
Peter, can you talk about the margins that they're getting? Evidently, they're not getting any margins on the hardware.
We're not stopping, we're not preventing them take margin on the hardware. You know, our recommendation is that we sell it cost across the entire supply chain, because that's the right thing to do for the customer. And then they make their margins, you know, on the software.
So are they buying the equipment then directly from, obviously, because Avnet's the distributor, so they're acquiring, Avnet is selling the gear directly to them without you being in the mix at all.
Correct.
Their consolidation.
Yeah, we don't care from a commercial perspective about the hardware.
Okay.
As Jeff talked about earlier, we care a lot about what they're buying in terms of the value of the hardware, and we absolutely support it and give it the 10-year lifespan that we've talked about before. But yes, the channel will buy directly from Avnet.
And then who does the maintenance on the hardware?
We do. So part of our license fee includes maintenance on the hardware.
So you have the agreement to do the break fix in the market then?
Yeah, correct. We include that as part of our license fee. So
do you subcontract that maintenance or do it yourself? Because, you know, given the potential geographical distribution that you're now talking about, that's no mean challenge.
Yeah, we are using third parties as most people do in some geographies, but we're keeping very tight Q&A control over that.
And Peter, one other question on the licensing. So the partner is making a margin on the software license. That is subscription based. So are they, do you have an amount of years that they're going to be the subscription and kind of earning that subscription over, or how does that work with them?
Yeah, it's completely flexible. So, you know, we can address subscription exactly as the customer wants it. So 1, 3, 5 years, whatever they would prefer. You know, and then we'll pay margin to the channel, depending on what they're buying for their customer.
Okay, so they're going to make a margin over if it's a 1-year contract, they make a margin, and then they have to go in there and renew that license in order to get the margin afterwards.
Yes, exactly. It becomes a subscription model, you know. So for many customers, that gives them the flexibility. You know, imagine the service provider market, which is becoming a growing market for us. You know, every year that they know what customers they have, they know how much capacity they're going to need. You know, they're not tied into a 5-year contract without, you know, with a lot of spare capacity. So it gives an incredible amount of flexibility.
Okay, thank you.
Thank you. So really, that's all I wanted to talk about. I want to open up to any questions you might have before I hand over to Sven. Sven was one of our very early hires in international, and so I'm delighted to see you keeping him so busy in the first half of this. But do you have any questions for me before I hand over to Sven?
Peter, my question is back to the original one I asked in text. You know, what markets are you actively going to be pursuing in Europe? It's a very mixed place, and presumably you're not going to be trying to, you know, skin all of the cats at once.
Yeah, you're quite right, Tony. We can't. You know, we will have channel partners in most markets, but we also know, you know, if I take it back to my initial comment that we know the customers where we can make a massive business impact, we've really carefully selected our markets based on where, you know, most prevalent areas for those customers are. So, you know, to be specific, you know, I want to answer your question specifically. We have got very big hubs and teams now in UK, Germany, and France. We're actively selling into South Africa. We're actively selling into Israel. We're actively selling into the Nordics and Benelux. We're about to put a team into the Middle East. We're actively selling into Australia and New Zealand. We have superb partners in Korea who are leading with our product. You know, we are recruiting into Japan, and we may well put a hub in Singapore. At the moment, I'm looking at different ways that I can address the Russian and Indian market, and I'm also looking at different ways that we can work with, you know, the GSI community to really accelerate the growth into other markets and the core markets we're talking to.
Peter, I have one more question on transaction. If the end user is not using a partner, how do they acquire the equipment?
So we're not going to prevent them buying directly from us or Avnet. We would, you know, for the scale of our business and, you know, shipping and transporting into the various markets around international, we would introduce them to a channel partner if we possibly can.
Okay, so they're going to buy it through a channel partner, through the Avnet is how they acquire all the equipment. Sorry, Jeff, I didn't mean to cut you off.
Yeah, they can buy directly from, you know, we'll sell our software through Avnet as well, if that makes it easier from a transactional.
But consider Avnet not a distributor, right? That business was sold to Tech Data many years ago.
Yeah.
Avnet's a contract manufacturer that anybody can buy from.
Yeah, I'm familiar with the folks that are doing that. So that's what I was trying to understand, how you guys were doing your transaction. Thanks.
Okay.
Okay. So Sven, you're on. Great pleasure to introduce Sven. He's CTO for all of International. Really great hire, and you know, all those questions you had, this is your chance.
Thank you, Peter, and great time obviously to be with VAS, right, and see how we are able to replicate this success around the globe now, and how we find all these nice people to move everything forward. So let me start sharing my screen. I promised you some answers, and I have a little less time left than I expected at this point, so I'll talk a bit faster or skip some things, but of course, as usual, interrupt me if you think you want to double click on something. And of course, I'm the field CTO, so I have the pleasure of telling you more about the technology behind our universal storage. And I guess it's clear at this point, and from what Jeff already told you, that our mission is to kill the hard drives, just because our customers need fast access to all of their data, right? So tiering really doesn't cut it for them, in the sense that, right, the tiering promise, or what people like to imply is, of course, from tiering, that you get away with buying a small piece of flash and then a big bunch of spinning disks behind it, and then you get for the price of a spinning disk system the always speed of an all-flash system, right? That's not how it works. That's only how it works if you're always accessing a small piece of your data, not if you really run modern analytics across all of your data. So it's clear what we want to change. It's maybe not obvious or seems impossible to actually change it, right? And replace all these with the economics of flash until it's actually done. So usually I would now show you our architecture and then derive from it all the great things, but I thought I'm in an experimental mood, and with so many smart people in the session, right, maybe we can do it the other way around and just try to build our architecture and reverse engineer it, and hopefully, if all goes well, we'll come out at the actual vast architecture, or worst case, you'll have another architecture in mind, and then we'll switch it, of course, right? But the good thing is that we can assume that we'll have the best developers in the world available for us, right? So we can just come up with ideas, and those are the guys who will be able to implement it. So what's the first problem that we need to solve if we want to become universal storage for all of the data large scale, right? That's obviously that flash is expensive. And people who say that haven't done their homework, because there is, of course, expensive flash, but there's also less expensive flash, like QLC drives, for instance, which VAST happens to be using. And of course, you also all have flash in your laptops these days, right? And your mobile phones. It's not too expensive for that. But the problem with the less expensive flash is that it typically has a lower endurance rating, especially for lots of small random writes, right? That tends to wear it out more quickly, which is of course not a problem if you're able to design an architecture that can just avoid these small random write accesses to the drives. So what can you do for that, right? The intuitive thing for that might be to use some RAM cache to try to gather the data or something like that. But as a matter of fact, right, if you have lots of small files being ingested and so on, then that small RAM cache doesn't help you at all. On the one hand, it's very small, so you need to get the data out quickly. And on the other hand, it doesn't change the location of the data on the drives, right? So small random stays small random on the drives. So what's the alternative that you have? And you already heard it from Jeff, kind of. Luckily, these days we have Intel Optane available. Almost unbreakable with respect to endurance and proven by our actual customers. Very fast, small random write speeds and a very convenient size. Of course, it's more expensive than QLC flash drives, but we only need a very small portion of it in the system, and it will still be a very convenient size to use as that intermediate staging buffer. So what we can do with it is we can ingest a lot of data first into the Optanes, and there we pre-aggregate it, and then afterwards we're able to write it out to the QLC drives in very large blocks, and that's very important to achieve that longevity, right? And there might in fact be temporary files that never make it to the QLC drives, right? Because it's just not worth it, because their lifetime is too short for that. So I want to emphasize here that this is not your ancestors simple write cache, what we're doing with the Optanes, right? It's really a staging buffer where we pre-aggregate the data and then intelligently regroup it to write it out in very large chunks to increase that endurance. And we're so sure about this mechanism that we're actually guaranteeing 10 years of warranty for the QLC drives. The other thing now that we have this large staging buffer is that it allows us to do very wide erasure coding. You might know from your typical storage vendor that they are doing something like 8+2 rates normally, right? That means actually you lose 20% of capacity. So you want to have 10 petabytes of usable capacity, right? You have to pay something like 12 petabytes, so 2 petabytes of capacity extra, which is just wasted for the fault tolerance. Now, the problem there again is that these mechanisms typically rely on very small write caches in RAM, so you can't really bring together a large chunk of data. But with our much more convenient staging buffer that we have in Optane here, it's almost trivial to do very wide striping, because we can conveniently gather a lot of data and then do very wide striping across actually 136 plus 4 drives in total, if the system is large enough for that, which gives you, as Jeff mentioned, 60 million years to data loss expected, right? And of course, we're monitoring all these wear out statistics of our customers who enable the call home. So we're sure that this is working well. And effectively, it means you only have a capacity loss of 2.7%, right? So the 10 petabyte of capacity that you buy are not only 8 petabyte, they are really almost 10 petabyte. Yeah, and then the other thing, once you have written a lot of data to these drives, at some point you need to do a garbage collection on these drives. So the other problem with that, with these drives, is that they have very large erase blocks. That means if you only free a small portion of such a large multiple 100 megabytes erase block, then internally the drive still needs to shuffle the data around and copy it partially to another block, so you're wearing it out even more. And for that, it's important that we added a mechanism that can actively predict the lifetime of data, right? So it can group data together that has an expected long lifetime, and it can group data together in an erase block that has expected short lifetime, so that we can be sure that it's almost freed all at the same time, so that the drive does not burn extra erase cycles for that. Usually I would double click on that. I hope it's clear at this abstract level. So I'll skip over the detailed slides for this, for the sake of time. The other thing when you're doing very wide erasure coding is usually that a restore after a failed drive becomes quite expensive, because if you're striping across 136 plus 4 drives, and use the classic old school Reed-Solomon codes, then to do the rebuild of a single drive, you actually need to read from these 136 remaining drives, right? So that would be a huge impact on the system. Luckily, nowadays there are new algorithms available which are called locally decodable erasure codes, and which allow you to read only from a small subset of such a large stripe to actually be able to restore the data. So that keeps the impact very low, of course, in such an event. But again, from our customer statistics, we see that the NVMe drives are very, very rarely failing at all, the way we're using them. So far, so good. Okay, then the other problem, and this is actually independent of all flash or spinning disks, right? The other problem is, of course, 10 petabyte of data are still 10 petabyte of data that you need to store. And the bigger the system is, right, the more you have to pay for the hardware, of course. So what can we do about that? And then the thing that automatically comes to mind is, of course, a data reduction mechanism. And we're certainly not the first company to think about that. But as you might also know, data reduction so far has been very limited effective, let's say, right? Why is that? On the one hand, you have the deduplication, which is rather coarse-grained. You actually need to find completely identical blocks with similar contents, right? And sometimes that happens because the users, right, really copy complete files and forget about them, okay, but it's not super effective. The other thing you had so far is what I would call on-the-fly compression, right? Data is compressed as it gets written into the system, so you only have a relatively small chunk of data that you can look at, which again limits the effectiveness of this compression. And typically it also only works within a single file. So even if there is rather similar data across files, you didn't catch it with the classic compression algorithms. And even if you did, and you would have had a spinning disk system, then it would be no fun at all to work with these systems, because if you would compress across files with such an algorithm, you would introduce so many disk seeks that the system would almost become unusable. But luckily, we have an all-flash system here, right? We're not bound by disk seeks. And the other thing that's relevant for dedupe is, of course, that you need rather big tables, which are usually kept in RAM with all the fingerprints of the different blocks that you have in the system. And so the approach that we've taken would not have been possible with a RAM cache, but luckily we have 3D Crosspoint here, right, which eats big hash tables for breakfast and has enough capacity for that. So I thought it might be funny to show an actual example of how our developers are looking at this, right? These are two completely different large files, and all the red bytes that you see here, this is a binary comparison, are different bytes, but all the black bytes that you see here, they are actually similar, right? Not necessarily in this at the same place in the other file, but they are repeated in the other file. So when our developers saw that, right, they knew that they can get something extra out of that if they can only achieve global data reduction, right? Compression against all the other data that is already stored in the system across files. And that's actually what we do. Thanks to a new class of hash algorithms that's available, we can not only find identical blocks across the existing data, we can also find similar blocks across the existing data, right? And then we can take our reference blocks that are already stored in the system from whatever file the user previously ingested, and can compress against that. And then we see that we get to this whole new level of effectiveness for the data reduction. And here I actually have an example which I want to bring up quickly. The impressive part here is that what we're looking at is already pre-compressed and pre-deduped data from a backup of several VMs, right? So let's look at what we do with that. And I would have loved to run this actually live, but it would have taken a bit too long. So what we have for our customers to find out what their data reduction ratio will be.
Can you blow it up? Yeah, great, thanks.
What did you say?
Blow it
yeah,
up.
okay,
You did.
larger font, yeah, okay. I hope it's large enough now. So what we provide to our customers to find out how much data reduction they will get out before they actually need to buy the hardware, right, is such what we call the probe tool. It analyzes an existing data set. It gets sent to the customer as a Docker container. And it tells you how much you get out of these 3 types of compression, right? So in this pre-deduplicated and pre-compressed data set, we find that there are still a number of duplicate chunks left, which only make about 1% of data reduction, so not much like expected. We find that our compression algorithm that works within a single file still is able to get another % out of that, so not super impressive. But then we come to our similarity-based data reduction that's unique in the industry, right? That really can compress against any data that's already in the system. And this is where we have the big gain, right? Out of a data set of almost 22 terabyte, we reduce it by 12 terabytes. So we get a data reduction factor of 2.28 to 1 out of pre-compressed and pre-deduplicated data. And that's, of course, I hope, very impressive. Okay. So we saw that. I'll skip over this for the sake of time, but I guess you can imagine, right? This is how we bring the cost so much down. This is actually one of our international customers based in Australia, down under geophysics. As you might expect, right, they are into geophysics, but they also offer HPC as a service, right? And they clearly say how much their service has improved now that all their data is on flash. And the only reason why they could even afford flash at this scale is because our data reduction brought the amount of hardware that they needed to buy so much down. Of course, in combination with the fact that we're able to use these cheaper flash drives in the first place. Good. And then the next problem that we needed to solve is, of course, that we want to make this enterprise ready, right? Which means it needs to be super easy and trivial to manage, but at the same time, it's an all-flash system. So customers, of course, expect a certain level of speed from their all-flash system, right? And then when we talk about enterprise ready and easy to manage, of course, people all love their NFS, or in general, their NAS filers for the easy management and for the convenience. But so far, at least that's what our ancestors used to think, right? That NFS and fast are really not compatible with each other. But where they are wrong was that they forgot about the fact that NFS is just the protocol. The protocol itself is not inherently fast or slow, right? It's the implementation behind the protocol that makes it fast or slow. So let's see what we get through NFS if we connect what I call the beast, an NVIDIA DGX A100 system, to one of our Lightspeed enclosures. The NVIDIA beast here happens to have 8 200 gigabit ports, which unlock more than 160 gigabytes per second. Our relatively small, only 2U Lightspeed enclosure comes with 4 100 gigabit ports, right, which is somewhat north of 40 gigabytes per second maximum. Our ancestors would have said that, yeah, well, NFS is a point-to-point connection, so you're limited to only one source and only one target interface, right, which brings it effectively down to a single 100 gigabit link here, which translates to somewhat north of 10 gigabytes per second. And right, you would not get anywhere near that with classic NFS implementations. So I see I'm running out of time, so I'll do this very quickly and run a benchmark where we have this DGX A100 on which we're now connected to such a single Lightspeed enclosure, which happens to come with 4 servers inside it, right, each delivering 100 gigabits per second. And we see that we're coming out north of 40 gigabytes per second, right? So that's the 400 gigabytes per second that we're really meeting at line speed of the Lightspeed enclosure here. So how is that possible? That's possible because in compliance with the NFS standard, oh, I need to move this a bit. We have extended the NFS implementation to actually support multipathing, right? So you're no longer limited to a single source and a single target interface. In fact, we're spreading the data here across all the interfaces of the DGX. And as a matter of fact, we're also doing the same on the server side, where this Lightspeed enclosure happens to come with 4 servers, as I said, right? And each of these 4 servers is contributing to the 40 gigabytes per second that we see, right? It's a bit off here, but you see that they are actually all delivering somewhat north of 10 gigabytes per second. So we've broken, right? We've broken that fundamental problem with NFS, that it was assumed to be slow, where it's actually not slow, right? It all depends on the implementation that you have behind it. And the reason why this is possible is because we have that shared storage in the background, right? The NFS client does not even need to be aware of which server it is sending the data to, because all the servers are stateless and all the servers can give the same reply, right? So the NFS client can just send the requests round robin to any of the servers and will get the right answer from it. And we could take this even further, right? Here we were limited by the single enclosure. We can really take that north of 160 gigabytes per second if we wanted to. So finally, let's connect the dots and bring up the architecture to which you hopefully agree this all ultimately leads, right? We have the cheap QLC drives in the enclosures. Before that, as a staging buffer, and for the file system metadata, we have our beloved Optane drives. And since we want the clients to be able to send the requests to any servers for perfect scale out, the drives need to be separated from the actual protocol servers like the NFS, SMB, or S3 servers. And that actually gives us perfect scalability, right? The same goes for an S3 client. It can also send its request to any of the servers and will always get the right answer. We want to have that longevity of the QLC drive, so that's why we have the Optane in front of it. Since the Optane is accessible by all of the protocol servers, similar to the QLC flash drives, right? The essential part here is that we took the drives out of the protocol servers and separated them so that each of the drives is available to all of the servers, and all of the servers can serve all of the namespace, right? That's a critical enabler for a lot of things. One is the linear performance scale that this enables. The other thing is that every server in the system now can contribute to the global algorithms, right? One global algorithm is, of course, the very wide erasure coding that we're doing across multiple boxes. The other thing is the global data reduction, of course, right? The hash tables for this are stored on the Optane drives, and we don't need to have multiple copies of it because each of the servers can just access each of the Optane drives. So that problem is also solved. And let me get the next one. Did anyone come out with a different architecture? Raise your hand now. But I guess not. Yeah, and as you might expect from the way we laid things out, right, it really has proven linear scalability, and we have these really large customers with dozens of petabytes stored on their vast systems in a single namespace that we can really say we have proven linear scalability.
Do you support stretched clusters, let's say in a metropolitan area and 2 data centers over some miles?
Not in a right synchronously mirrored way, if that's what you mean, because that would of course completely kill the write performance, but in a new way that we call native replication, where you can really have 2 geographically separate vast systems, and they can do live mirroring to each other. It's slightly asynchronous, right, with a time window of just a few seconds, but otherwise it's live mirroring to the other side.
Okay, thank you.
Okay, and then one of the questions that I previously received in the chat was about some kind of quality of service, right? Doug already mentioned it in the statement, in the customer statement that I showed you quickly, where they say that that quality of service among their different tenants is of course very important to them, right? Because they run HPC as a service, and with, for instance, a big spinning disk system, it would have been very easy to completely kill the streaming throughput of one customer when another customer comes and starts doing random reads on the drives, right? That makes them seek a lot and completely kills the streaming throughput and the whole experience for others. And that's fortunately not as easy with Flash, because disk seeks are completely eliminated, right? It doesn't matter where you access the flash drive next, it will be fast anyway. So that's good enough as a solution for most of our customers. But the ones who want to do more, they are able to actually build pools, right? You remember we have these HA enclosures with the NVMe drives in the background, which each of the protocol servers can access. But you can, if you want to, dedicate certain protocol servers only to certain workloads, right? In the case of Duck with HPC as a service, that could mean that they right, exclusively reserve some of the protocol servers to one of their tenants and some others to another tenant. Another model that some of our users are running is that they have the largest pool for their HPC system in the background, maybe, right? And then there's a small pool of protocol servers exclusively reserved for the interactive users, and maybe another small one as a backup pool. And this is API driven in the sense that from the VAS perspective, since each of these servers has access to the whole namespace anyways, it just means that we move IP addresses around if we ever want to change this, right? So while there might be interactive users over the day, there might not be interactive users over the night, right? So why not overnight just take some of these IP addresses associated with this pool and just spread them over to the interactive pool, right? So that your HPC jobs can run even faster during night, where you're not disturbing any of the interactive users. And then when the day comes, you automatically just move these IP addresses back into the exclusive batch pool, and the interactive users are again happy with their interactive experience. So it's an inherent quality of service mechanism by the way we did the architecture, right? A nice side effect, you could say. And this is actually my last slide, because as you know, right, our customers really want to put a lot of data on our systems typically. So once they did this, it would of course be a big pain on the one hand to ever move the data to a completely new system, right? And on the other hand, we're happy with all the customers that we have. So we want to do, of course, everything for them to never have a reason to move their data of a VAS system, not by locking them in any way, right? You can always copy the data of the system if you want to, but by avoiding that they would ever have a reason to move their data of an old generation of hardware onto a completely new generation of hardware. And remember, we're simply assuming for this game here that we have the best developers in the world, so we can just tell them, ensure software-wise, that old and new hardware generations are always compatible with each other, right? It's in the nature of things that, for instance, the new hardware generations will have larger drives, maybe faster drives, and maybe more CPU power, right? But they can just prepare for that. And so if there's a workload that consumes CPU, for instance, like a RAID rebuild, if it ever happens, right? Then the system can just say, okay, I'm sending more work to the servers that have more modern CPUs, for instance, right? The system, the software just needs to be aware of the fact that the servers are not all the same. And then it can conveniently take care of everything. Otherwise, it's just a matter of ensuring that the hardware can be plugged together, right? That's not such a big problem at all. And with that, I would hand it back over to Jeff.
Oh, that's cool. The slide's much prettier than when I originally wrote it. So we didn't take the full 20, but I just wanted to recap what we're all about. You know, the company is really focused on breaking trade-offs and solving the problem at the fundamental level so that customers get the biggest gain. And what we're really about is revolutionizing access to data and basically making every IO available in real time. You know, a lot of people talk about things like performance density. We talk about performance ubiquity. Once all of your data is on flash, you don't have to squeeze the absolute best performance out of an SSD because you just have so much more performance than what you could possibly use. And we think that fast access to all of your data is the foundation for the AI era. If you look at these codes and the way that they want to work with data, data scientists, AI researchers, they do not want to be constrained. But as long as there are physical constraints of the storage media that they're using, then they're never going to be able to realize their full potential. And the thing is that this is more than just like marketing hyperbole, right? We are affecting a movement in the industry. The customer adoption is rapid and it is extremely large. And I think that's testament not only to us having a game-changing concept at a time where people want fast access to all their data, but we have a product that just works and people can buy in very large quantities without worrying about their jobs. We're expanding very quickly into Europe now. I don't think Peter introduced himself maybe as much as we potentially could have, but previous to VAST, he managed the go-to-market push for Pure Storage in Europe. And so he's a seasoned professional that knows all the tricks, and we're going to be playing them as fast as we humanly can. And we've got a lot of systems already deployed and a lot of built-up demand all over the world. And what we're trying to do is basically change people's opinions about how they deal with storage tiering, how they think about scale out NAS and object storage, and just simplify everything into one composable and affordable flash cloud that is all you need for all your data. So thanks. Did we capture all of the questions? I think there's still one left.
I think, Jeff, there was a question by Tony Locke earlier up in the chat. That still needs to be, Tony was asking, how does latency consistency scale?
Sure. So there's two questions here. The first is latency consistency. The nice thing about the architecture is Sven was showing you these machines that drive our software, they don't talk to each other. So every machine that you add becomes a kind of an embarrassingly parallel addition to the overall cluster. And we now have customers, I think the largest that we've deployed has a few hundred file servers. And so long as you have hardware to keep up with the IO demands, it can scale completely linearly. That's one of the things that this DAYS architecture has implemented. And then as Sven was pointing out, latency is also, we put boundaries around IO through this concept of pooling, such that if you have applications that are particularly kind of hungry for IO and would otherwise ruin the experience for every other user on a storage system, you can put them in their own enclave using a pool and kind of fence off the performance or the latency impact for the other applications that aren't as voracious. So the whole objective is to not have any sort of communication east-west within the cluster. I think that's one of the real inventions that we pioneered here, is that there is no internal communication that happens across machines during any read or write operation. And that's how we preserve latency at scale.
As long as you've got the latency consistency and you can guarantee that latency consistency, that's probably the most important point. I'd still need some convincing about the absolute, linear scaling, because frankly, I've never witnessed that, and the mathematics says that it can't happen. You can get really close to it, and you probably do, but I doubt that it's absolutely, linear.
Well, in certain cases, it can be hyperlinear. And what do I mean by this? Well, as you build the system, the erasure codes get more efficient as you grow them. And as the erasure codes get more efficient, you actually get more productive SSD resources that can be applied to IO. And so our system, if you have one enclosure, is actually slower than if you had four.
This is why you need to stop using the term linear. consistency, because it's been linear scaling, because it's been so overworked and badly marketed for the last 20 years that frankly I'd explain it that way. You might find less resistance.
Okay, well, I think hyperlinear is even is more ambitious. You know, when we've told people that, they really don't believe you, and it's a fractional gain that you get, but it can go beyond linear. The next question is around MongoDB. Yep, I got it.
Oh, sorry, yeah. So you've got the MongoDB one. Thank you, Jeff.
Yeah, so solutions like Mongo, Postgres, other kind of modern applications that would expect a block store. We work a lot with Elastic and Splunk, for example. Typically, customers are deploying those when they need block storage in either a virtual machine or a container that provides a local volume. And scaling as such, but also most of these solutions also have support for S3, and so you can use fast object storage as the underlying storage for those applications as well. But we have customers that are using Postgres, we have customers that are using Mongo, and it all just works. As I mentioned, NFS has been kind of maligned in the industry as being a slow protocol, but if you can implement the protocol better, then you could use it for these demanding applications. Okay, any plans to refactor to provide container native storage? You seem part way there is the question from Anthony. We have a lot of plans in this space. And I would say that there are some specific hardware dependencies that we have today that really only apply at small scale. We could build very large infrastructures off of standard commodity resources if we wanted to, although we've resisted doing that just because the number one thing that we focus on is uptime and quality. And what we haven't done is we haven't ballooned out the approved vendor list for reasons that we just want to focus on one platform to QA and to make right in our early days. Now, as time goes on, I think we'll open that up a little bit more. We already have a few customers that are running our software in their containerized bare metal, or I should say containerized server environments. People run our software on Dell servers, people run our hardware on HP servers, our software on HP servers. But it is an exception to the rule, and it's not the one that we typically do when a customer just wants the easy button. But that said, there's still a lot that we intend to do and announce in this space, so stay tuned for that.
Okay, any more questions about the company, the product, the strategy, industry trends, or whether there's been anything you saw today that surprised you because you thought things were different somehow?
I got one question. What size racks are you using?
You can put it in standard meter depth racks.
Do you then support 21-inch OCP racks for hyperscalers?
We do not.
Are you planning on doing that?
We are not.